Yes, then, for the eye, there are some carotenoids that are very beneficial and essential. Beta-carotene is well known, and also the subject of most of this conference, the macular xanthophylls, lutein, zeaxanthin, mesozeaxanthin. Beta-carotene, the significance of beta-carotene has been known for a long time because it is the provitamin A. It provides the retinal, which we need as the photoreceptor in our visual pigments. And this is produced because carotene is cleaved to vitamin A and the retinal is used as part of rhodopsin and other visual pigments in the cells of the eye. If we don't get enough beta-carotene, then obviously there are consequences. This can lead to vitamin A deficiency, and in the context of the eye, vitamin A deficiency can lead to loss of the visual pigments, first seen as night blindness, inability to see in dim light, because it's the pigment rhodopsin which is affected first. But if this deficiency is prolonged, then this can lead to permanent blindness and destruction of the photoreceptor systems. Now, we nowadays tend to associate vitamin A deficiency with poorer societies, especially in tropical countries. But we must not forget that it used to be a problem in our own environments as well, in the West. And indeed, there are some quite early reports of vitamin A deficiency with religious fasting in Russia as far back as 1860. Then vitamin A deficiency could become a problem. And I also found some reports, strange reports, that the American Confederate Army in the 1860s suffered from quite a high incidence of night blindness due to vitamin A deficiency. Now, for us, this is not usually a problem because there are so many good sources of beta-carotene. Carrots, sweet potatoes, fruits such as mango and papaya, green vegetables, and if that's not enough, then there are plenty of supplements available. Let's look at some pictures, all familiar, but it's always nice to see pictures. Carrots, sweet potato, similar color, similar sort of concentration of beta-carotene in some of these. I show this because this is one of my favorites, mango and sticky rice. Mango has a lot of carotene in there, and various green leafy vegetables such as these baby spinach. So beta-carotene in our feast is generally not going to be a problem. We're going to get a lot of beta-carotene. What about the macular xanthophylls? What about their availability in our food? And let's look at zeaxanthin, lutein, and mesozeaxanthin. Where may we get these from in our food? And as you know, there is selectivity. In blood analysis, then usually zeaxanthin is present at a relatively low level, maybe only 1/10 of the level of lutein. Whereas in the macula, lutein and zeaxanthin are present in approximately, roughly equal amounts, and there's also mesozeaxanthin is a major contributor, significant part of that zeaxanthin. So what about sources of these macular xanthophylls in our diet? Well, lutein, there are many good dietary sources. Green leafy vegetables. Now, we think of green vegetables as being a good source of beta-carotene, but in fact there is more lutein in green vegetables than there is beta-carotene. So green vegetables are a very good source. And other greens, broccoli, other green vegetables, pumpkin and squash, various fruits, and egg yolk, of which we'll hear more, Again, some pictures, cabbages and things, cabbages and kale and broccoli. A book was published some years ago, believe it or not, with that title. Nothing to do with me. That was actually George Bush, who apparently did not like broccoli. Peas and beans also. Don't forget, peas and beans contain quite a lot of lutein. Squashes and pumpkins also. And egg yolk, of which we'll be hearing more later. Fruit. There is lutein in quite a lot of fruit. And a very good example is the banana. This nice yellow color of bananas is due to lutein esters. But what do? We throw it away and eat the useless stuff in the middle. And this is quite common, that in peel and skin of many kinds of foods, we actually throw away an awful lot of the carotenoid which is in there. Now, what about zeaxanthin? There are some, Antonio's already mentioned this, there are some good sources of zeaxanthin. Red and orange peppers have quite a lot of zeaxanthin. Maize, sweet corn, we'll hear presentations from Tim's lab about zeaxanthin in sweet corn. Zeaxanthin is a component in some fruit. There's also usually a little zeaxanthin in egg yolk, but egg yolk carotenoid composition does vary a lot. The Chinese, for centuries, have used goji berries because they're said to be good for eye health, and they are a very, very rich source of zeaxanthin. But also there is some zeaxanthin in green leafy vegetables. Sweet corn, peppers, goji berries. But what about zeaxanthin in leaves? Well, in green leaves, in photosynthetic systems, there is what's called the xanthophyll cycle, which is a protective mechanism. And this xanthophyll cycle, part of that cycle is zeaxanthin. And when this cycle is operating as a protective mechanism, the plants accumulate rather more zeaxanthin in high light conditions than they do in low light conditions. And from the point of view of food and nutrition, this means that the concentration of zeaxanthin in there varies during the day and varies depending on the climatic conditions. So the amount of zeaxanthin in any greens that you may eat may well depend on the time at which these were harvested. So something else that has to be taken into consideration. The zeaxanthin content overall is generally not high, maybe up to about 5% of the content of lutein. So if you eat the amount of leaves to give you, say, 5 milligrams of lutein, you would only get about 1/4 milligram of zeaxanthin. So you'd have to eat an awful lot of cabbage to get high amounts of zeaxanthin into your diet. Now, what about mesozeaxanthin, of which we hear more and more? Well, mesozeaxanthin has not been reported as naturally occurring very often. It has been found in egg yolk, and if chickens are fed and some synthetic zeaxanthin is included in the feed, synthetic zeaxanthin contains 50% of mesozeaxanthin, and this will be present to some extent in the egg yolk. And David, I know, is going to say more about mesozeaxanthin in egg yolk, so I won't dwell on that. Otherwise, the occurrence of mesozeaxanthin is quite often in fairly obscure sources. Retina, in the retina of birds and reptiles, there may be zeaxanthin in oil droplets. Now, I don't know about you, but I don't eat many of those. Also, it's a component of the zeaxanthin, which is present in skin and various other tissues in some fish. and also in tissues of some crustaceans. But generally, it's only a very minor component of this. This is a slide, and this is a picture of what are our main dietary sources of mesozeaxanthin. We could get some if we eat fish. We'd have to eat about this amount of fish a day. And generally, we'd be eating things like the skin and the fins of the fish, which I, for one, don't particularly fancy. So in a normal diet, normal food, no supplements or anything, the amount of mesozeaxanthin that we would be taking in is minimal, to say the least. Now, egg yolk. Egg yolks come in different shades. The yellow one here, paler yellow, likely to be pigmented by lutein. If there's some zeaxanthin in there, then you get a rather more orange color. You can, by using other carotenoids such as canthaxanthin, and get an even deeper orange color to the yolk. But egg yolk generally will accumulate whatever xanthophylls are present in the feed that the chickens are taking. Again, I'll say no more about this because I know David, according to the abstract, David's going to tell us more about that. Egg yolk, then I'll say no more about egg yolk, and what do? I put up another slide on egg yolk. But this just summarizes more or less what I said, that egg yolk accumulates xanthophylls, normally in the free form, and it gets them from whatever's in the feed. The chickens may be eating things derived from leaves or from maize or from marigolds or even synthetics or whatever. So we don't get much mesozeaxanthin. The other source of the macular xanthophylls would be supplements. And these supplements provide various mixtures, various compositions of lutein, zeaxanthin, mesozeaxanthin, often as a mixture. And evidence, as you know, is that these boost the macular pigment concentration, beneficial for the macula, beneficial for the brain. One thing that I would like to know is, do we know anything about the efficiency with which these different xanthophylls may be taken up or deposited from supplements? Usually they're given as mixtures, so it's not easy to find out this information. Maybe, I'm sure there are people who know more about that than I do. So, factors that contribute, if we don't have enough carotenoids, why might this be? Well, first of all, it's the availability of suitable food sources. For us, that's generally not a problem. Some parts of the world it is. Low bioavailability in its broadest sense. And Antonio said quite a bit about this. But one thing that we should not overlook is the importance of the structure of the food that we're eating and the physical state of the carotenoid within that food structure, because there can be many barriers and difficulties provided by these structures which make it difficult for us to digest and to absorb the carotenoids. There's also the risk of destruction during storage and processing. Again, Antonio alluded to this. One thing that is often overlooked, because you don't see it reported very often, is that if, for example, you want to eat some, what should we say, some lettuce leaves, then the mere fact of chopping the lettuce, cutting the lettuce, or chewing the lettuce releases enzymes, lipoxygenase enzymes, and these can actually destroy 30% of the beta-carotene within seconds. So any destruction of raw leaves can cause quite serious losses in carotenoids. particularly in beta-carotene. This seems not to be such a problem with the macular xanthophylls, or at least in the ones which have been studied. But that's something, again, which needs to be noted. Now, that's carotenoids in leaves, yeah. The difficulties of getting carotenoids from leaves, the structural matrix of the leaf, some leaves are quite tough and fibrous, difficult to digest. Once you break through that, you have to get through a cell wall into the chloroplasts with another barrier. In the chloroplasts, the carotenoids, carotene and lutein, they're present in pigment protein complexes where they're involved in photosynthesis. Beta-carotene in reaction center complexes, lutein in light harvesting antenna complexes. So we have to go through all these different levels of digestion before the required emulsifying fats are able to get at the carotenoids in there. In fruit and vegetables, again, we may have to digest through the structure. And some of these structures can be quite tough. I mean, you eat a raw carrot, it's almost like eating a piece of wood. They're so tough. And then you've got to break this down, got to get through the cell wall again. And here the carotenoids are present in chromoplasts, also organelles within the cells. But within the chromoplasts, the carotenoids are present in different physical states. The carotene may be present as crystals, as it is in the carrot. And if it's present in crystals, then it's much more difficult to dissolve. The xanthophylls in fruit, they are usually present as esters, and they're often in structures like liquid crystals or even oil droplets, so they are likely to be easier to assimilate from there. Carrot cells with these dark spots, which are carotene crystals. Not very clear on that picture. Now, what I've said so far is related to the availability of these various carotenoids in our food nowadays. But maybe we can learn something if we go back in time. The older you get, then the more you look back in time. So for me, it's very easy. And we think of what might have been available many years ago to primitive people. And here is a person of a very primitive, picture of a very primitive person. Primitive people tended to adorn themselves with various ornamentation. But if you look very carefully at the face, you can see just how primitive this person really is. Oh, I can see someone waving at me at the back there. This was actually taken when Antonio was working with me in Liverpool. It came as quite as a surprise when he turned up like this. But so if we look at what may have been available in the diet of early people, for many early people, especially if we think about, shall we say, European people, then the diet would consist of mainly things like leaves and roots, and if you're lucky, some nuts and grains and things as well. But centuries ago, thousands of years ago, certainly in our climate, there would have been no really carotenoid-rich exotic fruits. They were still in undiscovered parts of the world. We might get some xanthophylls in egg yolk, and seafood, which does provide some carotenoids, would generally only be available to people who live near enough to the coast to be able to go out and harvest it for themselves. This cartoon is something which I often see reproduced, about early vegetarians returning from the kill with their prize. Now, the person who produced this cartoon obviously was not there at the time, because they've shown a picture of an orange carrot, one of these. But orange carrots as we know them didn't appear until the 17th century, when they were first cultivated in the Netherlands. Before that, carrots were sort of little white and weedy things, sounds a bit like me, and didn't have any carotene in there at all. So although we get a lot of carotene from carrots, years ago people didn't. And although they were living on a diet of leaves and roots, then for roots, before Columbus, there were no potatoes. They were in South America. There were no sweet potatoes in here. There were no orange carrots. There may have been some turnips, which had low concentrations of carotene, but not very much. We wouldn't get much carotenoid from roots. The main zeaxanthin sources that are available to us also originate in the Americas. So there were no peppers, no sweet corn, no goji berries. They were still something mysterious in China. And the tropical fruit and vegetables that we now get so much carotenoid from, they either were not available at all or were just not affordable. Leaves. Therefore, people had to rely on leaves. And a diet of leaves was the main source of carotenoids in those times. They would provide beta-carotene and lutein, but not generally in very high quality. Wild cabbage is quite small and weedy and very leathery leaves, and you would need an awful lot to provide enough carotene and lutein that we now believe that we need. You probably have to eat many kilos a day to provide sufficient amounts of zeaxanthin, for example. Maybe 100 kilos of leaves a day. Do you want to eat 100 kilos of cabbage each day? I don't think I would. Although they did eat some leaves, or so it seems. These are the kind of cabbages that might have been available. So you'd be living on a diet of this kind of stuff, rather than eating large amounts of our own cabbages. Also, in those days, egg yolk is pigmented by xanthophylls, but in those days, virtually only xanthophylls from leaves. There was no manufactured feed that was given. The chickens were out scratching for whatever they could find. So in those days, there would probably be no zeaxanthin finding its way into egg yolk and no mesozeaxanthin. Egg yolk, if it was yellow, which it would be, would have only lutein. So for our ancestors, our primitive ancestors, for them to get macular pigment, what was available? Essentially only lutein. Very little zeaxanthin and no mesozeaxanthin. Now the macula, as we know, and as we're finding out more and more, the brain, need the macular xanthophylls, the macula needs zeaxanthin. So if we go back to our ancestors, the only possibility to get zeaxanthin into the macula was likely to be by conversion from lutein, because there was no zeaxanthin available to them. And by conversion of lutein, this would give mesozeaxanthin, so the macula would only have lutein and mesozea. All speculation. There'd be no, what we would call normal zeaxanthin from the diet, and normal zeaxanthin only became available recently when sources of zeaxanthin were available to all of us. Does that help us in any way? I don't know, but I think it's something that we should think about, that we think about our diet being rich in so many carotenoids, but we developed from ancestors whose access to carotenoids was severely restricted, and maybe they were only getting appreciable amounts of beta-carotene and lutein. So we may well have evolved whatever uses we make of these compounds at an early stage. Now, beta-carotene, it's been known for a long time that beta-carotene is so important. But also we're finding that lutein is more and more important. This in many ways makes sense because these are the main carotenoids in leaves in the diets of our ancestors. So maybe we are on the right lines after all. So thank you. Thank you. Oh, I've gone red.
Thank you so much, George, for that